In this video, I will explain a solving strategy that can be used for drawing the 1,2 and 1,4 addition products of dienes. If we have a conjugated diene, and this conjugated diene reacts with HX, then instead of getting only one product, actually we'll get two, again because of resonance. These two products will be called the 1,2 and 1,4 addition products. In order to draw these products, all what you have to do is just number your diene. So starting from any side toward the other one. Now it doesn't really matter if you start from left to right or from right to left because the diene is symmetrical, and the case of unsymmetrical dienes is not covered in this video. So it doesn't really matter, start from from left to right or from right to left. And the first product, which is a 1,2 product, is drawn by removing the double bond which is between positions 1 and 2, and then adding hydrogen at position 1, carbon number 1, and adding X at carbon number 2. And this is your 1,2 addition product. To draw the 1,4 product, the two double bonds will disappear, and then a new double bond will appear between positions 2 and 3. And this is of course because of resonance, so definitely you have to refer to the mechanism to see how does this work. Now hydrogen will be always added to position 1 and X will be added to position 4. And this is how you draw the 1,4 products. For example, let's say we were given this conjugated diene and we were asked to draw the products of the reaction with HBr. Again, just number the double bonds starting from left to right or right to left. So 1, 2, 3, 4. To draw the 1,2 product, I will just remove the double bond which is between positions 1 and 2. And I will put hydrogen here. So always hydrogen will go to position 1 and Br or Cl will go to position 2. And then to draw the 1,4 product, I will move the double bond. So this is 1, 2, 3, 4. The double bond will be between 2 and 3. Hydrogen will be at 1, and then Br will be at position 4. So this is the 1, 2, this is 1, 4. Let's take one more example. Let's say we were given this system. Again, numbering from 1, 2, 3, 4, or from up to down, that's same thing, HCl. Draw the 1, 2 product. So keep the double bond which is between 3 and 4 in the same position. Just put H here, put Cl here, and this is the first product, the 1, 2. To draw the 1, 4, I will move the double bond to be between positions 2 and 3, and then my hydrogen goes here and Cl goes here. Let's take one more example. Let's say we were given this diene, again with HCl. It doesn't really matter how you start. Let's see, 1, 2, 3, 4. My first product could be obtained by just putting hydrogen here and Cl here. And this is the 1, 2 product. And then I can draw the 1, 4 product by moving the double bond to be between positions 2 and 3. And then my hydrogen will be here and Cl will be here. So this is how we draw the 1, 2 and 1, 4 addition products. Now, the major and minor products depend actually on the temperature. At high temperatures, the 1, 4 product, which is called a thermodynamic product, will be the major one. Whereas at low temperature, the 1, 2 product or the kinetic product will be the major one. So for example, let's say this reaction was run at 0 degrees, and this is considered as a low temperature, and the 1, 2 will be the major one. Let's say this one was run at 100 degrees. In this case, this is a high temperature, and that's why the 1,4 product will be the major one. Let's say this was at 80 degrees. Again, this is a high temperature. So this is the 1, 2, this is the 1, 4. So this will be the major product. Now, 1, 2, and 1, 4 addition products of dienes can also be obtained if we have halogen, which is X2 instead of HX. But the reaction follows the same solving strategy. So in this case, I will just remove the double bond between 1 and 2, and I will put, in this case, 2X. So at 1 and 2, and the other product could be obtained by moving the double bond to be between 2 and 3. And now this is the first X, and this is the second X. It doesn't really matter how you draw the directions of X, so up and down, it doesn't really matter. Let's say again, we were given, for example, this diene, and the reaction is with Br2 and 0 degrees. So 1, 2, 3, 4. First product is obtained by just putting Br here and Br here, plus the 1, 4 product is obtained by moving the double bond between 2 and 3. And now the first Br will be at position 1, but the second one will be at position 4. Let's say we have a cyclic system. Again, Cl2, 0 degrees, low temperature, 1, 2, 3, 4, or the other way around. Cl, double bond goes here, or move your double bond, put it here, Cl goes here, Cl goes here. And the major and minor products depend on the temperature. Here you have to pay attention to something. And this is only specific for the case of X2. If the reaction conditions are X2 and heat, sometimes instead of getting the 1, 2 and 1, 4, allylic bromination may occur, or allylic halogenation may occur, which is the one that was explained in the one of the previous videos. So when does this happen? This happens if you have a conjugated diene with an allylic position that has a hydrogen, such as in this case. So, and this only should be if you have X2 and heat. So at low temperatures, this doesn't work. So let's say in this case, we were asked to complete the reaction, Br2 and heat. So this is X2 and heat. So also this doesn't apply if we have HX. So this is only specific for X2 and heat. In this case, Br2 and heat, instead of doing the 1, 4 and 1, 2 and 1, 4 addition product, actually allylic bromination occurs. So the numbering will be 1, 2, 3, or from the other side. And then in this case, I'm not going to touch this double bond. I'm not going to touch this double bond. And I will just add Br here at position 1. So this is the same as the previous video, which is a free radical allylic halogenation. And then I will move the double bond to be at, so this double bond will move to be between 1 and 2, and Br will sit here. So this is the only difference. If you have X2 and heat and you have a system with allylic position that has hydrogens, then this work. For example, in this case here. So let's say you were given this diene. For example, in this case, even if I have X2 and heat, I will still get 1, 2, and 1, 4. Why? Because this is the only allylic position that I have, and it doesn't have hydrogens. So I will just draw the 1, 2, and 1, 4 products. But let's say, for example, we had one more branch here, then yes, allylic halogenation will take place, and now this is 1, this is 2, this is 3, and now my Cl will be at this position. And